Alright, let's solve the question above. It says three beams have the same length, same allowable bending stress, and the same bending moment. If the three beams are having the same allowable bending stress and the same bending moment, it means their sectional modulus are also equal. So the cross section of the beams are a square rectangle with depth twice the width and a circle. So we want to find the ratio of the width of circle and rectangle beam with respect to what square beam. You have to take note of that. All right. So for you to solve this question and draw these diagrams. So this one is representing a square because it's having the same length and breadth. And this is our rectangle, and this is our our circle. So for us to start with this question, we'll start with the section modulus of a square. All right, we are going to denote the section modulus of this square with Z1. So we know that section modulus is moment of inertia over y max. All right, and we know that the moment of inertia of a square is similar to that of a rectangle. So it's going to be bd cubed over 12 divided by, and y mass. Y mass is the distance from the bottom to the neutral axis. So it's going to be what? D over what? Over 2. So this will be equals to bd cubed all over 12 multiplied by 2 all over what? D. 2 here 1, 2 here 6, D here 1, D here is 2. So this will be equals to bd squared all over what? 6. So this will be equals to, we know that the base and the depth is what? X. So it's going to be S multiplied by S squared divided by 6. So this will be equals to S cubed divided by 6. So let's call this equation number 1. All right. So the next one is our section modulus 2. So this will be for the what? Rectangle. So we know that the formula for section modulus is moment of inertia over y mass. So this will be equals to the moment of inertia here is going to be what? Bd cubed over 12. Then divided by the y mass is also the distance from the bottom to the neutral axis. So this is going to be what? It's going to be d divided by what? By 2. All right. So this will be equals to bd cubed over 12 multiplied by 2 all over what? Over d. 2 here 1, 2 here 6, d here 1, d here 2. So we can further write this as what? So this can be written as bd squared over what? Over 6. So this will be equals to our base. The base is b and the depth is 2b. So it's going to be b multiplied by 2b all squared divided by 6. So this will be equals to 2 square is 4, b square is b square, and b square multiplied by b is going to be b cubed. So we are going to have this to be 4b squared divided by what? 6. Sorry, 4b cubed. All right. So 2 here is 2 and 2 here is 3. So we can rewrite this as 2b cubed divided by 3. So and we know that our base is still b, so no need of any substitution. So let's just call this equation number 2. All right. So the last but not the least is the sectional modulus of a cycle. So this will be Z3. So which is the moment of inertia over y max. So this will be equals to, what is the moment of inertia of a cycle? This is pi d to power 4 divided by 64. Pi d to the power of 4 all over 64. And our y mass is the distance from the bottom to the neutral axis, which is still d divided by 2. So this is going to be pi d to the power of 4 all over 64 multiplied by 2 divided by d. 2 here 1, 2 here is 32. D here 1, D here is 3. So this will be equals to pi d to the power of 3 all over what? 32. All right. So let's call this equation number 3. All right. So the next thing we are going to do is we are going to be equating equation 1 with equation number 2 and equation 1 with equation number 3, because we are told to keep our square beam constant. Alright, so let's start with equation 1. So equation 1 is s to the power of 3 divided by 6 will be equals to equation number 2, that is 2b cubed divided by 3, right? Alright, so here we are going to make b the subject. So for us to do that, so this is going to be times 3, that is this is going to be 6 times 2b cubed, that is 12b cubed, which will be equals to 3s cubed, right? So we can divide both sides by 12, right? So to do that, this is going to be 12 will go in 12, 3 here 1, 3 here 6, right? So it shows that b to the power of 3 will be equals to 1 over 6, sorry, 1 over 4 rather. 3 here 1, 3 in 12 is 4, not 6. All right, so this is going to be 1 over 4 s cubed, right? All right, and then we know that 1 divided by 4 is 0.25. So this is going to be equals to 0.25 s cubed. All right, so for us to get the value of b now, we are going to take the cube root of both sides. So it shows that b will be equals to 0.25 all to the power of 1 over 3 then s, because this one is having cube, so it's also having cube. All right, so if you take the cube root of 0.25, so we are going to have this to be 0.63. So we are going to have this to be 0.63 s. So it shows that our b is equals to 0.63 s. All right, so let's call this one equation number 4. All right, so the next thing we are going to do is we are going to equate equation 1 with equation number 3. So we're also going to have s cubed divided by what? Divided by 6 to be equals to pi d to the power of 3 divided by 32. So here we want to make d the subject. So this is going to be 32 multiplied by this, then divided by 6 pi. So it shows that d to the power of 3 will be equals to 32 divided by 6 pi, then multiply by s to the power of 3. All right, again, for us to get the value of d, we are going to take the cube root of both sides. So it shows that d will be equals to 32 all over 6 pi all to the power of 1 over 3 s. Yeah, so now if you press this value in your calculator, 32 divided by 6 pi to the power of 1 over 3, you are going to have this to be 1.1927. So this is going to be 1.1927 s. So it shows that our d now is equals to 1.1927 s. All right, so we are going to clean this part. All right, so you are going to note carefully that the weight of a beam is proportional to their corresponding cross-section area. All right, so it means that we can say that the weight of a rectangle over the weight of this square is going to be equals to the area of this rectangle over what? The area of this square. Don't forget, we are keeping square beam constant. So weight of our rectangular beam all over weight of the square beam will be equals to area of rectangular beam over area of square beam. I hope you know rectangular beam, square beam. All right, so now this will be equals to, now what is the area of a rectangle? The area of a rectangle is what? Length times what? Times breadth. So it's going to be b multiplied by what? 2b. So we are going to have b multiplied by 2b all over the area of a square. The area of a square is just going to be what? S square. S square. So this will be equals to, now we already know the value of our b to be what? 0.63s. So we can substitute that here. So if we do that, we are going to have 0.63s multiplied by 2 multiplied by 0.63s. Sorry, please, let me just clean and rewrite. All right. So we are going to say that this is equals to 0.63s multiplied by 2 multiplied by 0.63s divided by s square, right? And you know this s times s here is s square, so it shows that this s and this s will go with this. So if you multiply 0.063 multiplied by 2 multiplied by 0.063, you are going to have 0.7998. all right, so this will be the first solution. All right, next again, the weight of our circular beam all over the weight of our square beam will be equals to area of our circular beam all over what? All over area of square beam. All right, so again, this will be equals to the area of a circle. The area of a circle is what? Pi d squared all over what? All over 4. So pi d squared all over 4, then divided by the area of our circular beam. Area of our circular beam, area of our square beam rather. Our square is just s square, right? All right, so we can write this to be equals to s d all square all over what? 4s square. All right, so if we substitute for our d here, our d is 0. So this will be equals to pi multiplied by 1.1927s all squared all over 4s square. All right. All right, so this now will be equals to, if we try and split what we have here, so this place will not contain it. So let me manage the space. All right, so this is going to be pi. This is going to be equals to pi multiplied by our d, which is 1.1927s all squared all over 4 multiplied by s squared. So if you try and open the bracket, we are going to have pi multiplied by 1.1927 squared multiplied by s squared divided by 4s squared. So this s squared will go with this s squared. So you'll be left with pi multiplied by 1.92 squared divided by 4. And if you press that, your final answer is going to be 1.1172. Our final answer is going to be 1.1172. All right. So here is the solution of this question, and I believe we understand this. Thanks.